Alright, so let's take a look at the domain and range of the 6 trig functions. Remember, domain, that's x values or what can I plug in. Range, that's y values or what do I get out. So that's like the answers that you get when you evaluate the 6 trig functions at an angle measure. Alright, so let's first look at sine. Alright, the sine function has a domain of all real numbers. So you could either write out all real numbers, or one way to write all real numbers in interval notation, negative infinity to infinity. So what that means is you can take the sine of any angle measure. Okay, now what we get out, though, our answers that we always get will be between -1 and 1 inclusive, meaning it could also be -1 or 1. So the range bracket -1 to 1 bracket. The brackets mean we include those values. So pretty easy to write the range by just using the interval notation as well. The cosine function is going to be the same as the sine function. The domain, you can take the cosine of anything. The range, all of our answers that we get out when we take the cosine of something, will always be between -1 and 1 inclusive. So you can't take the sine or cosine of an angle measure and get out 2. Alright, that's outside of the range, so it's not possible. Alright, the tangent function. Alright, so what can I take the tangent of? Well, if you remember, tangent is y divided by x. So since it's a fraction, anytime that x equals 0, we have a problem, right? If tangent is y divided by x, then anytime that bottom of that fraction is 0, we have a problem. Well, so we just want to leave out all those times when x will be equal to 0. So we could say all real numbers except odd integer multiples of pi over 2. That's going to be the times when x is equal to 0. So all real numbers except odd integer multiples of pi over 2, or 90 degrees. Let's look and see, what does that actually mean? Let's read through that again. All real numbers except odd integer multiples of pi over 2, or 90 degrees. So where is pi over 2, or 90 degrees? Let me go down a little bit. So if this is pi over 2, or 90 degrees, we have a problem here because this is where x equals 0, right? Where's another problem? Down here. And then if we can go more than 360 degrees, so, or pi over 2. So if we have a problem here and here, then every time that I go around this axis, or I go around a revolution, either way, forward or backward, I'm still going to have a problem at whatever multiple of pi over 2 or whatever multiple of 3 pi over 2 I'm at. So that's why it says odd integer multiples. So odd integer multiples would be, 1 times pi over 2 is pi over 2. 3 times pi over 2 is 3 pi over 2. 5 times pi over 2 is 5 pi over 2. 7 times pi over 2, 7 pi over 2. So anytime we're at a multiple, an odd integer multiple, pi over 2, tangent has a problem. It's undefined. So that's why we leave that out of the domain. If to write that in interval notation, it probably, I mean, you could write some interval notation for this, like all real numbers, except I don't want to get too deep into math symbols, but it's probably, so it would be better just to write it out like that. I'm not going to ask you on a test what is the domain of tangent. What this does, though, if you can understand it, is that whenever, say, you're taking the tangent of pi over 2, and you remember, oh wait, that's a place where tangent's undefined. Or say you're working out the tangent of 9 pi over 2. And you say, oh wait, okay, that's 9 times pi over 2, and 9 is odd, so that's a place where tangent's undefined. So understanding the domain and range can actually help you work out problems. Okay? So the range, what can you get out? Well, since tangent is y over x, it's a fraction. When you start dividing y divided by x, you can get anything out. So if you can get anything out, that means the range is going to be all real numbers. Okay. Now let's look at their reciprocals. Let's first look at cosecant. Cosecant is the reciprocal of sine. So what can we take the cosecant of? Well, since, remember, it's the reciprocal of sine, so if sine is y divided by r, cosecant is r divided by y. So anytime that y is equal to 0, I have a problem with cosecant. So that means it's going to be all real numbers except the times when y is equal to 0. So let's think about when are the times when y is equal to 0. And so if we were to look at that same xy axis here, it's 0 or 2 pi radians, pi 180 degrees. Alright, so the times when y are equal to 0 are when we're at 0 radians or pi radians, 0 degrees or 180 degrees. So that's going, the way that we can write that is we can say all real numbers except integer multiples of pi. So like 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Or we could say 0 pi, which is 0, or negative pi, negative 2 pi, negative 3 pi. So all real numbers except integer multiples of pi, or 180 degrees. So all real numbers except integer multiples of pi. It can be when pi is odd as well. 1 pi, so it's when it's odd or even, but you can just say integer multiples of pi, and that includes everything. So what answers can we get out for cosecant? Well, since sine, its range is from -1 to 1. That's the answers you get out. And the way that it works with the reciprocal is that it will actually not be any of the numbers between -1 and 1. It will be everything that is less than or equal to -1 and greater than or equal to 1. So the way that we can write that, the range for cosecant, it's from -infinity to -1 with a bracket because it can equal -1, and, or union with, 1 to infinity. So that means all the answers that I get out when I take the cosecant of something will be less than or equal to -1 and greater than or equal to 1. Secant, remember secant is 1 divided by x, or r divided by x. So anytime x is equal to 0, we have a problem with secant. Well, didn't we have another function that was like that? Anytime x is equal to 0, we have a problem. That was the same for tangent. So it's going to have the same domain as tangent. All real numbers except odd integer multiples of pi over 2 or 90 degrees. So you could say the same as tangent, but I'll write it out again. Alright, what can I get out for secant? Remember, secant is the reciprocal of cosine. So if cosine, if all of its answers are going to be between -1 and 1 inclusive, then it's going to be the same as cosecant. It's going to be everything less than or equal to -1 and everything greater than or equal to 1. Alright, one trig function left. That's cotangent. Remember, cotangent is x divided by y. So when do we have a problem with cotangent? When y equals 0. Okay, we had another trig function up here that had a problem when y was equal to 0. Cosecant was 1 divided, or r divided by y, so it also had a problem. So it's going to have the same cotangent, is going to have the same domain as cosecant. All real numbers except integer multiples of pi. Or 180 degrees. Alright, cotangent is the fraction x divided by y. So that means its range, it can really be anything, because if you're dividing numbers, you can figure out a way to get every number, right? So its range is from -infinity to +infinity.